This video represents 2 days work with Business Centre Heavy Construction Edition on the Toowoomba Second Range Crossing. First of all, we're just going to use a coordinate system, and I'm just going to use a recently used published coordinate system. Now we're going to grab our files and just drag and drop them in. And our point cloud file is just going to confirm what coordinates they are in. And we see all those files on. So let's hide this disclaimer text. And what we're going to do is go and grab all the point cloud data and use that to create our existing surface. Alright, so we'll turn that off, and what we're going to do is have a look at all this design data, and we're going to take the main alignments, MC00 and MC10 in this case, and create a surface out of that. And what we expect to see from the data provided is maybe some flags showing crossing break lines. And this particular set of data, because it was designed in 2 sets, there's a common string in each alignment at the barrier, one on top of the other by a small offset, so we can see them there. Now I want to go ahead and start editing these, but before I do so, I'm going to change the properties of this surface to rebuild by user. Let's just stop it retriangulating every time I edit strings. So I'm going to go and break away all the duplicate sections here and get rid of those. So I've just about finished getting rid of all those sections, and now I'm going to manually rebuild that surface. Now we can see I've resolved all those flags. Now those strings, as I said, I broke away where the duplicates are, but what I now have is a set of broken strings running the full set of the alignment. So I'm going to use the advanced select function to select all those strings by name, their barrier. They all start with CB. I get some out on the edges as well, but that's not going to matter. And I'm going to run the join command and join all. Now this will join all strings that have a common end. So that broken up string will now be joined from one end to the other. And we'll do a quick check. And we see it's connected all the way up to the location of a bridge. And what we're seeing here is some big triangles running around the place. And what we're going to do is change the properties of this surface to associate it with the alignment and specify that it's alignment based. And once again, I'm going to rebuild this because I've set it not to do so automatically. And we'll see all the triangles now are aligned with sort of cross sections of the design. We see a couple of other flags come up, so we'll have a quick look at these. I'm going to deal with these ones in 3D. Now remember, I've got it set to build by user. So it's not updating, no, but I'll select and rebuild, and those flags are resolved. On this side, what I've done is actually set it to rebuild automatically. So you'll notice as I edit, it's automatically updating. This is a great function to see what you're doing, but can sometimes cause it to be a bit tedious as it rebuilds everything. Now I'm going to run a function called project cleanup, and in particular I'm going to reduce line vertices. Now reduce line vertices strips out any points along a string that doesn't define geometry. And you'll see here it's stripped away 16,000 extra bits of data along there. Now to compensate that, so because a lot of software will triangulate along those points, what we have here is a function to sample strings, regardless whether there's points on it, at every 5-meter interval or if there's deflection of more than a certain distance. Alright, so what we're going to do is tidy up the edges here, so trim away some of the excess triangles. So just finishing up here. Now, if I made a change somewhere and it reran the triangulation algorithm, all those triangles will appear, so I don't want that to happen again. So I'm going to create a surface edge break line. This surface edge break line is a 3D line and it gets added to the model, but it can change how some of the triangulation forms since it's a 3D string. So what I'm going to do is remove it from the model. And you'll notice all those triangles are going to come back again. But then I'm going to strip the elevation away from it. And then I'm going to add it just purely as a 2D boundary to this surface. And so there's our final design all done. Now I might go ahead and just change some of these line colors just to make it look a little bit prettier based on their names. Alright, all done. So what we want to do now is set up a corridor. So we're going to do that on MC00. We'll give this corridor a name. And we're also going to specify the original ground for our volume calculations. We're going to reference all the strings that we want to use in the cross sections. Now we'll set our chainage for our first template. And I'm just going to use a typical pavement template here I'm going to generate. Now corridors, like surfaces, will update the triangulation as we edit the corridor. So I'm going to set this one to show empty, so we're not going to get any triangulation built until I'm ready for it. Now, what I'm going to do to start with is use the surface that we've created as the finished level surface. So I'm just going to define that surface here. And now I'm going to just vertically offset some portions of that design, the pavement sections, to give us the underside of some pavement. Do the same for the other carriageway. Out on the edge we want to project that pavement grade, and we want to have that hit the design batter. So we'll just define that again on the left and right sides. And we'll continue building up this template. Alright, so here we've got a template with the earthworks model behind some of the barriers there, the bottom of all the pavement. And what we can do is go back to our properties of that. We're going to define our current layer as subgrade, and we're going to build that surface. Alright, so we get some of that sort of big chunky blocky triangulation similar to what we saw when we did the surface. So we might go through and, like the surface, we're going to specify that it is alignment based and rebuild it once again. And here we go, and if we go and have a look at a cut section down here, we can see the design strings, finished level design strings, floating above that earthworks model. It's boxed out nicely and underneath the barriers in the middle. And so here our design is finished. What we want to do is start preparing to do a mass haul, and we want to include some of the local streets. So we're going to go to the data marketplace built in within Business Center. We're going to search for our location here. Now I'm going to select a boundary for the extents of the project, and I'm going to place an order for the open street map data available from the government. So I'm just going to place that order. I've just set up some free login details that you can go through and do that. Notice there's no cost for this open data. That order's submitted. I'm going to get a notification to say when it's ready. So I'm going to go to the orders. I can see my outstanding orders here, so I'm going to click download. I was going to grab a heap of little shape files, so it's important we have the coordinate system defined. Lots of little files is where we're seeing them all churn through here, and we get everything from local roads, parks, structures, all that kind of thing. And there we can see it all. Right, it's a massive data, and you can see it's all layered out based on the shapefiles. Now I also want to grab a Google Earth image to place in the background here. So I'm going to create a couple of arbitrary points I'm going to export to Google Earth and use to reference an image back. I'm going to give them just an arbitrary height, 400 meters in this case will do, and export them out directly to Google Earth. Now, at the time of recording this video, Google Earth Pro was free. I recommend getting it. Some great tools in there. Now, we can see those points. Now, I'm also going to load in Google Earth the Queensland Government database of imagery and terrain. And what I'm going to take a notice here is the elevation reported within Google Earth for these points. And I'm going to assign those elevations back to the points in Business Center. Now, this will improve the accuracy of the location of those points on that imagery in Google Earth. So when I do capture an image and use those points to reference it, we're going to get a much better match up to those points. So I'll quickly go through and do these. So they're ready to be re-exported. Okay, it's just going to override the previous export. Now I'm just going to orientate this so I can get as much graphic there as possible by getting those points in the corners. And I'm going to choose to save this image. Now, Google Earth Pro allows me to choose the maximum zoom scale of the extents of this image. So obviously as we zoom in, the resolution often improves, or that this is actually going to save that full resolution to the onto the image. I see all the points there. I'll save the image. Now if I open this image back up, just in a normal image viewer, Windows image viewer, and adjust it to 100% scale, you'll notice it's quite large. It's several screens worth. So it's going to give me a much better image. So I'll drag that into Business Center. Now it's just going to use like a place, so I'm going to turn that off. And I'm actually going to use a geo-reference, which allows me to define some coordinates. I'm going to use 4 for the 4 points I've done. I can go and find these points. I'll graphically pick the pixel and then select the point that I used to export, and I'll repeat for all 4 points. And I'll register that. And you see now our image lines up perfectly with our open data and our project. So that Google image is going to help me identify the local roads that I'm going to be using to haul material about the project, outside the project extents. So I'm going to start selecting those roads that I want. I don't want everything in here, so I'm going to pick out the ones that I want and do a bit of tidy up and prepare these. Now, one of the other great things about this open data is the attributes that come within it. So each of these roads has the road name come through the attribute. So I'm actually just copying that down onto the string names. All right, now that I have that all prepared, I'm going to select the lot and convert it all to haul roads. And it's going to use those string names as the haul roads. All right, so we have a heap of haul roads off around the project. So we're going to set up a few locations where we can source some material. So we have a quarry here down near the rail. So we'll specify the entrance to that quarry. We have another quarry up on the ridge of this mountain here. So we're going to put that one in as well. And we also have a site where we can get rid of any spoil material that we have. So there's a farm here, we can get rid of our excess unusable material. Our mass haul editor, we can go through and see all those items that we've defined, and we can start associating costs of materials to buy, costs to haul along particular roads. With those complete, we're also going to set up our haul ranges. So we're going to define our dozer, maximum push for a dozer. And we're also going to specify that a dozer only works along the alignment, similar with a scraper and a moxie. Now we need to consider material going on and off the site. So what I want to do is set up truck and dogs for all the material being bought from quarries. So it's going to come from off-site to the alignment. And finally, we want to use just some site tippers to take material away from the site. We can see those also now in the mass haul editor, so we can adjust any limits on distance. Okay, so we're ready to process our mass haul. So I might just turn a few things on and off here. I might also change some colors here so it stand out a little bit better on that imagery. So I'm going to set up a mass haul, specify the corridor and the sample distance that's going to be used for all the processing and volumes. I'm not respecting site capacity, so I'm saying that any material that we might need can be available from the nearest quarry. I'm going to put in a barrier here, so there's a bridge to be constructed just down the bottom end here. So I'm just going to click to say at this location there's a barrier, so we can't haul along the alignment where this bridge is to be built. Okay, so now we're going to go ahead and we'll create our mass haul diagram. So this will run through a volume process and plot our cut and fill unusable material. What we see in that graph is some vertical steps, and those vertical steps are where material is either imported or exported off-site. In this case here, we see material being exported from one location along the alignment and hauled back onto the alignment where fill is required. So let's go ahead and balance this now. And here is our balanced mass haul. So we can see all our balance lines and our shading. Our zones have been shaded up on the plan view. Now, as we click on any item, again in either view, the dynamic and the opposite will highlight. So here we can see an imported material. We can see the details and the properties of it, and we can see what fill that's going to. If we browse around, let's have a look at a few other things. So this haul that we were looking at before, going around, in this case we're taking out of a cut there up the north, travelling down through a road to provide fill after the bridge. And that's going to be done by a truck and dog. We can have a look here at the excess material that's going to be hauled out. We get volumes and costs based on our haul rates down those particular roads and costs to get rid of material on site. Again, we can click on here, we see a scraper one, that particular cut, working to a couple of fills. So we can see here all those objects really dynamic. We can drill down and have a look at the detailed information, click on particular leads, import, export items in the graph, click on the graphic objects, get them highlighted, we see the properties of them all reporting out. We have a look at this little operation here, we can see a dozer balance there. We step out, we see it's scraper, and a second scraper operation from a different cut. So to get some reports out, first of all we're going to run a corridor earthworks report. So we'll get a breakdown of all the material at a particular chainage interval. In this case we're going to run it straight out to Excel. So here we can see all our materials, borrows, balances. We can see where material's been imported to complete the earthworks and where we have a barrier. We can also run a balance line report, so we'll get a summary for each of our different plant types, and we also get a breakdown of the volumes for each of those leads, where from, where to, and the volume, as well as any sort of material based summaries, particularly if we have strata. Now we can also export this mass haul to Tilos, Trimble project planning package, where each lead can be scheduled and costs applied. We can also set up and export to VisionLink. Our VisionLink is a 3D project monitoring system where we can collect real-time data from our machines and survey equipment and compare that and monitor it against our mass haul that we've prepared here. VisionLink has a web-based interface, so it can be accessed from anywhere where an internet connection is available, making it really simple to monitor the progress of a project. Now, once this mass haul is exported, a copy of the current mass haul is archived for some historical purposes, and we are left with an active mass haul. We can collect our data back from VisionLink, update our as constructed service, and re-optimize that mass haul based on the current state of the project. Last but not least, we want to get the data out to our fleet of equipment and survey gear. So we're going to set up a job site and we're going to pick our controllers that are synchronizing with Trimble Connected Community. We're going to set up our design. We've got our subgrade ready to go. We built with the corridor. We're going to assign that to all our devices, a combination of machines and hand controllers, and an emulator so we can test things out. We define our surface, our line work, which we can just grab by layer, And those files are generated and ready to synchronize. We're going to pop open Office Synchronizer, log in. We'll get the status of our equipment out there so we can see that some files to upload, and we'll upload the new data to all that fleet. It's ready to go.